Okay, this video is going to be on the repair of a flap control module off of a Bombardier-8. So here I got the unit, just kind of giving it a 360, giving you an overall view. This particular unit came in because the RVDT would not align, meaning that I don't work on this particular aircraft, so I don't know the exact nomenclature of what module or flight control computer this goes to, but I'd assume this gives a signal so that the appropriate actuators and associated components control the flaps to extend and retract them. So a bad RVDT would give you a faulty signal, and that would cause a fault, and I would guess it caused some kind of difficulty in controlling the flaps, or maybe not, because I could see there's a mechanical linkage. So I think it just has to do with maybe something more automated, some more integrated electronic system. It's not my job, but I'm just making assumptions. So here I'm just taking the screws off to remove the top panel to get into the unit. It has a little bit of dust, so I'm going to get ready to start cleaning it up. Here I'm looking at the manual. It says you can clean it with isopropyl alcohol, blowing some compressed air, getting my alcohol, using a soft bristle brush to brush off all the gunk and grime from the dust that's accumulated, and just kind of the I don't even know what you'd call that like caked on dirt that pilots put on stuff over years and years of use, putting their hands on the handle and spilled coffee, you know, just the dirty pilots. Now I'm gonna clean that up here. I got the RVDT, is a brand new one, giving a good look at it. 5 wires, taking off the little panel that gives you access to the installed RVDT. There it is, got that off. 3 screws holding on the RVDT. And there's a little clamp, like a little half clamp that secures it to the housing. I'm taking off the receptacle. It's not really a back shell. It's like a bonding cover. I don't know the exact name of it. It helps bond the shielding of all the wires to the frame of the unit. So first I have to take the 4 mounting screws for the receptacle off, so that I can access the screw on the other side of that half shell cover thingamabob. Just cleaning it up some more. To take the light label off, there's still some tucked away gunk in there. Here I got a little non-metallic scraper to further scrape some of that gunk off, so it gets tucked in everywhere. Keep calling it gunk. It's like that brown stuff. It's almost like a clay type consistency. It's really, really gross. It's like a combination of dirt and dead skin. Clipping off the zip ties. You gotta do it really carefully though, as to not nick any of the shielding, the sheath, or the insulation of the wires. Taking off the other screw to fully remove that back shell. Put that in my handy dandy bin. Here there's a, it's like a, what do you even call that? Like a lead clamp. It goes around all the shielded cables to hold them tightly together, and then that also serves as a point of contact to that back shell I just removed. Here, using my pin extractor to depin the connector to remove the RVDT connections. Really small pins, so you got to use a green and white pin extractor. Got them all out. Now I can just remove the whole RVDT, and voila, there it's out. And I got to transfer all the labels. Here I'm taking this one out. Pretty sure the manufacturer has a nice label printer where they could just get a piece of pink heat shrink, print the label on it, and then just install it. But we don't have that, so I reuse this as to not do something that's not going to look as good, like getting a piece of heat shrink and trying to Sharpie on it or something like that. Here I'm mocking it up, making sure my length is correct so I don't cut it too short, man, because these parts are really expensive. So it'd be quite the screw up to cut the wires too short. Here I'm putting on all the labels. These little labels mark each wire by number to the corresponding hole in the connector that they go in. Here I'm crimping on pins. You probably notice the crimper I'm using doesn't have a die or a locator on it. It's just one of those things. What can I say? But I ensure they're crimped on properly and to the right length. Give that little tug. Make sure they're secured on. Start installing the back of the connector now in their correct hole. Super imperative you do this correctly too. You switch wires around and next thing you know it doesn't work. You gotta undo it all. So you gotta test your stuff when you're done with it, obviously. Yeah, I'm using the tweezers to give a little tug, make sure that the wire locked into the connector properly. Using a little Scotch-Brite to clean up these back shell halves. Just make the unit look a little nicer, pretty it up real good. Then I'm putting on that lead clamp. I don't know what that thing is called, but it crimps around all the wires to bundle them together. So here I use my non-marine pliers to really clamp it into place, draw it in to a small circle so it can fit once I put the back shell halves back on. A little bit of Loctite. FE282. Okay, so let's see. So 7 volts, 3.2. 7 volts are. What's the 7 volts? 7. Little finicky knob here, and then frequency was 3.2K. Okay, now let's verify that output. And it was on A phase. Wow, look at that, right on the money. And then our frequency, 3.2K. Okay. So we're good to take this, plug this in here. Anti-backlash gears, get them aligned, and it's supposed to be like at close to -2. Yeah, and then I'll fine adjust it. Oh, beautiful. They usually don't go in that easily. Get all this extra stuff out the way. Get my screw starter. Oh no, actually I'm gonna need it. I'm gonna need it again. So we're gonna snug this down. Okay, now we gotta pull this pin out. I know, very okay. Until I get the right two. Let's see that, some of the values again. So this is not the right CMM. So right here. And then your 0.080 is the tolerance. It doesn't really look like it's seated. Oh, why are these threads so stubborn? 2.08 accuracy. No, it's still too far. 0.080. Yeah, no, we're still good. Zero. Let's see, just that bouncing value. Let's see if we get a little closer. Yeah, maybe we'll focus on the zero. Try to clock it from the zero. So we're getting this thing set up. I just changed at the final test before delivery, beginning of electrical test, lighting panel removed. And you only do this test when you change any electrical components. So all RVDT wires and all other wires connected to the frame, and the values it gives you. So we'll set that up. We'll see if we have any settings programmed to that. So let's see what we got. This thing is already putting voltage out of it. I feel it like zapping me a little bit. getting ready to do the final assembly of the unit, and then prep and mask it for paint so I can make the unit look nice and pretty. Realizing I don't have any of the videos where I put the light label on and the top panel, just kind of annoying. But here it is. I carefully taped off and covered everything so that everything could be appropriately painted the correct color. There it is. So all I have to show the final product is a picture, annoyingly enough. But everything was done in accordance with the manufacturer's manuals and all local and federal regulations. Everything torqued to spec and passed the test successfully. Thanks for watching my video.